You know, there are some questions that are so huge, we usually just leave them to philosophy or faith. But today, we're taking on the biggest one of all, and we're putting it under the microscope of science. We're going to look at the evidence from neuroscience, from physics, and from the quantum realm to ask a question that, frankly, science was never supposed to touch. So let's just dive right in. What really happens when we die?
Okay, picture this. A 57-year-old man in Georgia has a massive cardiac arrest. He is, for all intents and purposes, clinically dead. Doctors are working on him like crazy, trying to bring him back. 3 days later, he wakes up, and he says those words. But then, he starts describing the entire resuscitation scene from a vantage point floating near the ceiling. He recounts details he had absolutely no way of knowing, like the color of a specific nurse's mask, a piece of equipment that got dropped on the floor, even the exact panicked words a doctor was about to shout.
And here's where it gets absolutely wild. This is the scientific impossibility of it all. For the entire 23 minutes he was clinically dead, the man's EEG, that's the machine measuring the brain's electrical activity, it showed a completely flat line. Nothing. Zero activity. Medically speaking, our brain is the hardware for consciousness. When it's off, everything should be off. Consciousness, memory, perception, none of it should have been possible. So, how in the world could he see, hear, and remember anything?
This one single, baffling case just cracks open a whole universe of questions. I mean, is death really the final shutdown, the pulling of the plug we've always just assumed it to be? Or could it be something else entirely? A moment of transition, maybe? A fundamental change in the state of our consciousness? Well, we're going to go on an expedition to find out, starting with the biology of the dying brain, then diving into the unbreakable laws of the universe, and finally into the bizarre world of quantum physics.
All right, let's start right at the frontier of medical science. Those few critical minutes right after the heart stops beating. Most of us think that's just the end of the line, but for the brain, it might just be the explosive beginning of its most spectacular and, well, mysterious performance.
So what you're looking at here is data from a groundbreaking study out of the University of Michigan. Researchers measured the brain activity of rats at the exact moment of cardiac arrest, and what they found was just astonishing. In the 30 seconds after their heart stopped, their brains didn't just fizzle out. No, they erupted with a massive, coherent surge of high-frequency gamma waves. We're talking levels 8 to 12 times higher than their normal, fully conscious, wide-awake state.
And listen, these aren't just random electrical spasms. Gamma waves are the brainwaves associated with our absolute highest states of consciousness, flow states, big moments of insight, solving complex problems. As the lead researcher, Dr. Jimo Borjigan, suggests, this doesn't look like a system shutting down in chaos. It looks way more like a system performing one final, massive, hyper-organized data-saving operation. It's like a computer frantically saving a lifetime's worth of files to the cloud in its final seconds.
And this isn't just happening in lab rats. Dr. Sam Parnia at Southampton University led the biggest study ever on this, called the AWARE study. It was a massive deal. 4 years, 15 hospitals across the US, UK, and Austria, tracking over 2,000 cardiac arrest patients. Now get this. Of the survivors who could actually be interviewed, a staggering 39% reported having some form of awareness while they were clinically dead. No heartbeat and supposedly no brain function.
Some of these patients remembered real events from the operating room that happened a full 3 minutes after their heart had stopped. That should be medically impossible, since the brain's cortex is supposed to go completely silent within 30 seconds of losing oxygen. And this is what led Dr. Parnia to a really radical hypothesis. What if the brain isn't the factory that creates consciousness? What if it's more like an antenna, a biological receiver that's just tuning into a signal that exists independently of it?
Now, of course, skeptics often dismiss these near-death experiences, or NDEs, as just hallucinations from an oxygen-starved brain. But a long-term study by a Dutch cardiologist, Dr. Pim van Lommel, found something remarkable. Across the board, people who had NDEs consistently reported profound, positive, and permanent life changes. So if it's just a random chemical hallucination, why does it have such a consistent, predictable, and transformative effect on people's lives? It's a pattern that really demands a better explanation.
Okay, so the biological evidence is pretty compelling, but it leaves us with an even bigger question. If consciousness can exist without brain function, where does it go? To tackle that, let's pivot to physics, because in the universe there are rules, and one of the most fundamental, unbreakable rules is that nothing is ever, ever truly lost. Right, so we've all heard that energy can't be created or destroyed. Well, physicists now believe the exact same thing is true for information. Think of it like this. If you burn a book, the story seems like it's gone. But all the information that made up that book, every atom of paper and ink,
It's all still in the universe. It's just been transformed into ash and smoke and heat. The information is scrambled, sure, but it's not deleted. This principle says that every single bit of data that describes a system can never, ever just vanish.
I mean, this very idea was at the heart of a 40-year scientific war started by Stephen Hawking himself. He originally argued that black holes were the one exception to the rule, that they were these cosmic furnaces that destroyed information forever. But by 2020, the scientific consensus had completely flipped, and this just illustrates the point perfectly. Even at the edge of the most extreme object in the entire cosmos, information isn't lost. It's encoded and preserved on the black hole's event horizon.
So here's the crucial point. If the universe fights so hard to preserve the information of a single particle falling into a black hole, what about the immense, complex, beautiful amount of information that makes you, you? We're talking about the data stored in 60 trillion cells. All your memories, your personality, your fears, your loves. Does the most complex information system we know of just get a free pass to be deleted? The laws of physics scream no.
So where could all that personal information possibly go? Well, one of the most mind-bending theories out there, championed by physicist Leonard Susskind, is called the holographic principle. It suggests that our three-dimensional reality might just be a projection of information that's stored on a two-dimensional surface at the very edge of the universe. In this view, your conscious information isn't just inside your head. It's fundamentally and non-locally woven into the very fabric of space-time itself.
And now we venture into the strangest territory of all, the quantum realm. This is where the solid, predictable world we know just dissolves into a haze of probabilities and paradoxes. It's where the line between you, the observer, and the universe you are observing completely breaks down. So, yeah, prepare for things to get weird.
To really get a handle on the quantum perspective, let's go back to that receiver idea, because it is the perfect analogy. Imagine your brain is a radio. All around you, right now, are invisible radio waves, concerts, news, talk shows, flying through the air. You only hear the music when you turn the radio on and tune it to the right frequency. But if you smash the radio, does the broadcast, the music itself, stop existing? Of course not. It's still there. Death, in this analogy, isn't the end of the broadcast of your consciousness. It's just the breaking of one particular receiver.
And this isn't just some nice metaphor. The famous double-slit experiment demonstrates a verified, bizarre truth about reality. When you shoot an electron at a screen with two slits, but you don't watch it, it behaves like a wave of pure possibility, passing through both slits at the exact same time. But, and this is the crazy part, the moment you put a detector there to see which slit it goes through, its behavior fundamentally changes. It chooses a path and acts like a solid little particle.
I mean, just let that sink in for a second. Think about what that really means. Before it was observed, the electron only existed as a wave of potential futures. The active measurement of a conscious observer simply looking at it forced it to collapse into one single definite reality. This isn't philosophy. This is the bedrock of quantum mechanics. It means our consciousness isn't just a passive spectator of the universe. It is an active participant in co-creating it, moment by moment.
So, what happens to all those other possibilities that weren't chosen? Well, the many worlds interpretation, first proposed by Hugh Everett III, has a pretty radical answer. It suggests that the wave of possibility never actually collapses. Instead, every single time a quantum choice is made, the universe literally splits. Every possible outcome happens, each in its own brand new parallel timeline.
And this leads to maybe the most startling idea of all, quantum immortality. The logic is actually chillingly simple. If your consciousness is what's doing the observing, it can only exist in a universe where it continues to observe. So at any moment that could lead to your death, a car crash, a falling rock, the universe splits. And while countless versions of you might die in all those other universes, your conscious experience will always and necessarily follow the path into the universe where you, by some miracle, survive. You would never even be aware of the realities where you didn't make it. Your story just keeps going.
Okay, so let's try and bring all these threads together. We have biology suggesting the brain's final act is a massive data-saving event. We have physics insisting that information can never ever be destroyed. And we have quantum mechanics implying that consciousness is fundamental to the creation of reality itself. So, what if we reframe death not as a deletion but as an information update? Maybe an upload to the cosmic hard drive.
Two leading-edge scientific theories are pointing to exactly this conclusion, and they're coming from totally different directions. The OR theory, from physicists Sir Roger Penrose and Stuart Hameroff, suggests that consciousness is quantum information processed in our brain cells. At death, this quantum info isn't destroyed, it's just released back into the fundamental quantum field of the universe. Meanwhile, Giulio Tononi's integrated information theory defines consciousness with a mathematical value, called phi. At death, your unique personal phi value isn't erased, it's simply redistributed back into the cosmic system.
The language is different, but the destination is pretty much the same. Whether you see it as quantum data rejoining a universal field or an informational value being redistributed, both theories paint a picture of death not as an end, but as a profound transformation. The hardware might fail, yeah, but the software, the information that is you, is conserved by the laws of the universe.
So let's end with this thought. If science itself is pointing towards a reality where your information, your essence, is never truly lost, it kind of reframes everything, doesn't it? It means this life right here, right now, is the data you are writing. It's the information you are becoming. It's the record that's being kept. So if some future version of you, some other form, could access the memory of this existence, what is the one single memory you would want it to have? What data are you creating today?